Okay, today's lesson is on finding the distance between 2 points. We're going to continue to use the Pythagorean theorem for this because the distance between 2 points can be found by drawing a right triangle. We're going to use graph paper for this so that we can make sure that the right triangles come out to have a perfect right angle, very similar to when we drew slope triangles. So the length of the segment that you're looking for is actually going to be the hypotenuse of the right triangle that we draw. So that's the first thing, is making sure that your notes are filled in at the top. Therefore, the Pythagorean theorem can be used to find the distance between any 2 points on the graph. So the first question we have to do together is determine the distance between these 2 points. So the point -2, -3, remember, is located down here in this third quadrant. You had to go over 2, that's the x value. You had to go down 3, that's your y value. And then the second point that you're going to plot has positive values, 3 and 4. So we're going to go over 3 and up 4 to get to this point, which is up here in the first quadrant. So what you're going to do is you're going to connect your 2 points with a ruler to get a nice straight line. Now we can't get the distance of this straight line unless we go ahead and use a right triangle. So you're going to also use your ruler to come straight down from that top point and then go straight over until you're connecting the 2 points that you drew. Now if you'd like to use 2 different colored pencils, that's very helpful because then you can keep track of what you have and what you're looking for. We're looking for this distance here from point to point. And that ends up being the hypotenuse of a right triangle. This right triangle we know is a right triangle when we come straight down with our graph paper and straight over. What we need to know is how far this segment is right here, which is the leg, and here's our other leg of our right triangle. So remember, when you're counting boxes, you're going to kind of count these bunny hops. Each bunny hop represents 1 unit. So we have 1, 2, 3, 4, 5, 6, 7 units here. And we have 1, 2, 3, 4, 5 units here. If you're having trouble counting the segments that form the legs of your right triangle, let me know and I'll help you out. So over here we have room to do our solving. We know our equation is going to be the Pythagorean theorem, a squared plus b squared equals c squared. We also know that we're looking for this hypotenuse, which remember is your longest segment. It's always across from your right angle. So x is going to go here in our formula. And that's going to leave room for both legs. Our legs are 5 and 7. So you can plug in your legs, 5 and 7, on this side for a and b. You can simplify by taking 5 squared, which is 5 times 5, or 25, and 7 squared, which is 7 times 7, or 49. Now you're going to simplify by adding together these 2 values, which are right next to each other in our equation. They add together to be 74. And at this point of the problem, you're almost done. Remember, there's no way these connect forming 74 units, so we need to remember that the very last step is to solve for x. Taking the square root of x squared gives us x. Taking the square root of both sides keeps your equation balanced. The square root of 74 is 8.602325267. Okay, so you'll recognize this number hopefully as being an irrational number. Irrational numbers have a decimal value that goes on and on and on without repetition. And typically they're going to ask us to round our answers off, sometimes to the nearest hundredth. For this example, to the nearest tenth. So remember, tenths place is the first digit to the right of your decimal point. When you look next door, you can see it's going to keep at 8.6 units for the length of our segment. And that makes sense because this distance here, if we kind of estimate with our pen, it's a little bit longer than this distance here that we had that was 7. This always has to be our longest side of the right triangle. So basically that's it. Besides having to graph the points and connect them carefully and making yourself a right triangle, you're still utilizing the Pythagorean theorem that we learned about, and you're still solving using square roots at the very end of your equation. Your next 3 examples are on this full sheet of paper, and each example is very similar. You have 2 points to plot. You have to draw your right triangle, which remember is going to entail having to come straight down. You probably should use a ruler. And straight over. So if you can carefully go straight down And then make sure you stop so that when you go straight over, you're basically forming the legs on your right triangle. Once you have your right triangle sketched, remember you're counting boxes. 1, 2, 3, 4, 5. We have a leg of 5, and we have 1, 2, 3, 4, 5, 6, 7. We have the same values as our last example, so your work is going to be very similar. However, you may want to plug in your 5 and your 7 differently to show that they will come out with the same solution. And again, we're rounding to the nearest tenth. So again, it was 8.6. Pause the video. Try the next question. Make sure that you have your points connected correctly and that you draw your right triangle. Once you do this, go ahead and click play so you can check your answer. Okay, for this next example, you had to plot the point -3, 5, and you had to plot your second point at 4, -4. So this creates a very long segment that we're looking for the distance of. Your right triangle, remember, is going to go straight down and straight over to form a right triangle. This gave you a distance of 7 units. This gave you a distance of 9 units. So remember, your legs make up the right angle in any right triangle. So our legs are going to go in as our a squared and our b squared. So you can see we have our 9 squared plus 7 squared. That gives you your 81 plus 49. Remember, we're looking for that hypotenuse, so we'll use the variable x. And when you get to this point, you're going to square root both sides. So for this question, we should get 11.4. And for the last one, again, pause this video in a second. Once you have your points set up correctly, you have to graph the point -5 up 4, and then you have to plot the point 1, -2. You're going to create yourself a right triangle, and then you're going to go through the Pythagorean theorem to find the distance. So again, pause your video, and then when you're finished, hit play so you can check your answer. Okay, for this last example, if you connected your points and you made a right triangle with legs of 6 and 6, you will plug them in. 6 squared plus 6 squared, remember 36 and 36 gives you 72. We're looking for that hypotenuse of x, so remember at the very end you're going to square root 72, and this gives you approximately 8.5.